Section 5.6 is using multiplicative inverses to solve equations. I can use multiplicative inverses to solve equations. That's our learning target and what we're shooting for. To solve an equation that has a fractional coefficient, we can multiply each side of the equation by the fraction's multiplicative inverse. The multiplicative inverse of a non-zero number is the number's reciprocal. So we know that we can get rid of multiplication by dividing, but if the coefficient is a fraction, when we divide by a fraction, we multiply by the reciprocal. So here we're just going to skip that step and go ahead and multiply by our multiplicative inverse, which is our reciprocal, right away. So our multiplicative inverse property says the product of a number and its multiplicative inverse is 1. So 3/5 times 5/3 is 1, and that's the same definition as we had for reciprocal. In example 1, it wants us to solve. Right now x is being multiplied, so usually we would divide. But here, since it's being multiplied by a fraction, instead of dividing, we multiply both sides by its reciprocal, its multiplicative inverse. What this gives me is 28 over 28 times x, which is just x, 1 times x. So here, 12 over 1, we can reduce right away. Between 12 and 4, I can take a 4 out of both. 4 divided by 4 is 1. 12 divided by 4 is 3, which means what I have here is negative 3 times 7 over 1 times 1. And that's going to give me negative 21 over 1, which is just negative 21. So again, we saw that x was being multiplied, so we got rid of it since it was being multiplied by a fraction by multiplying by its reciprocal, its multiplicative inverse. We did that to both sides. On the left side, what that gave me is 7 times 4, 28 over 4 times 7, 28. And 28 over 28 is just 1x, which is perfect. Then, on the right side, I went ahead and simplified. In my numerator and denominator, I had a common 4, so I took those out, multiplied, reduced, and got x equals negative 21. In example 2, we're going to solve. So again, k is being multiplied by a fraction. So in order to get rid of our multiplication by a fraction, we multiply by the reciprocal. And if I change one side, I have to change both sides. Now, on my left side, my 7 cancels with my 7, and my 8 cancels with my 8. A negative and a negative cancel. So here I have just k, 1k equals my 56 I can put over 1. And I'm going to look. Here, 56 and 7 have a common factor of 7. I can take a 7 out of each of them. So I have 8 times negative 8 over 1 times 1, which means negative 64 over 1. And we don't need the over 1 because if we divide there, we do get just negative 64. So again, here I took multiplied by my reciprocal, negative 8 over 7. My 8's canceled, my 7's canceled, my negatives canceled. I got just 1. And that k equals, on the other side I reduced, multiplied, simplified, and got negative 64. Here we're going to solve the equation and check our solution. So m is being multiplied. We get rid of multiplying by a fraction by multiplying by the reciprocal. And if I change one side of my equation, I have to change both. This gives me 30 over 30, so 1m. I can write 20 as 20 over 1, and I can reduce here. 5 divided by 5 is 1, and 20 divided by 5 is 4. So what I have is 4 times 6 over 1 times 1. So I get m equals 24 over 1. And anything divided by 1 is itself. So here I get 24. To check, we plug it in. So I'm going to take 5/6 times 24, and that should equal 20. Plugged it in for m. I can write it over 1. Here I'm going to go ahead and reduce. 6 goes into 6 one time and into 24 4 times, which gives me 5 times 4 over 1 times 1 should equal 20. Gives me 20 over 1 should equal 20, and anything divided by itself, anything divided by 1 is itself. So here I get 20 equals 20. It checks. We are good. In example 2, we're going to solve a two-step equation. So here my x is being multiplied and added. I'm going to get rid of my addition first by subtracting. I do this the same way that I would if my equation was whole numbers and integers like we've done before. So I have a negative 11 over 15x equals 1/3 minus 4/5. Now this 1/3 minus 4/5, I need to simplify. Common denominator between 3 and 5 is 15. I have to multiply 3 by 5 to get a common 15. And if I change my denominator, I also have to change my numerator. To go from 5 to 15, I have to multiply by 3. If I change my denominator, I have to change my numerator, which gives me 12. Now, since I have a common denominator, I can keep my denominator, perform my operations on my numerator, and I'm going to get negative 7 over 15. That still equals negative 11 over 15x. Now, x is being multiplied by a fraction, so I get rid of it by multiplying by the reciprocal. 15 goes to the top, 11 to the bottom, and it stays negative. If I change one side, I have to change both. Now I can reduce if possible. 15 goes into 15 once and into 15 once. So here I have x equals negative 7 times negative 1 over 1 times 11. On my left side, my reciprocals, when I multiply them together, gives me just 1. I can simplify here and I get positive 7 over 11. So x equals 7 over 11. In example 4, we're going to solve as well. So g is being multiplied and added. So again, I get rid of addition by subtracting. And whatever I do to one side, I have to do to both. This is going to give me 13 over 16 minus 1/2 equals 3/8 times g. Half minus half is 0. Now I need to get a common denominator here. Between 16 and 2 it is 16. So I'm going to change them both to be 16. My first fraction, 13 over 16, I don't have to do anything to. I already have that common denominator. But to make it go from a 2 to a 16, I have to multiply by 8. If I change my denominator, I also have to change my numerator. Now, I have a common denominator, so I can keep my denominator, perform the operations on my numerator. 13 minus 8 is 5 over 16, and that equals 3/8 g. Now, g is being multiplied by 3/8, so to get rid of that fraction, I multiply by the reciprocal, because this gives me 24 over 24, which is 1. And 1 times anything is itself. That's how we get just g. If I change one side, I have to change both. So since I multiplied by 8/3 on my right side, I have to do it on my left side as well. Here I'm going to try and simplify if I can. 8 goes into 8 once, into 16 twice. So what I have right now is 1 times 5 over 3 times 2 equals g. I can simplify, which gives me 5 over 6 equals g. And that's because, remember when we multiply fractions, we multiply them straight across. So 1 times 5 in my numerator, 3 times 2 in my denominator. Okay, here, n is being multiplied by 3/4 and subtracted by 20. So, to get rid of my subtraction, I'm going to add. Remember, we add or subtract first to get our variable term by itself. Since I added 20 to the left side, or to the right side, I have to do it to the left side. So here I get 4 equals 3/4 n. Different signs subtract, give the sign of the bigger number. Now, n is being multiplied by 3/4, so I multiply by the reciprocal, 4 over 3. And if I change the left side, or right side, I have to change the left side as well. This gives me 12 over 12 on the right side, which is just 1n, which is what we want. On the left side, I can write 4 over 1, and we multiply straight across. This gives me 16 over 3. Now, 16 is bigger than 3, so I'm going to go ahead and divide to switch this into a mixed number. 3 goes into 16 5 times, which is 15. We subtract and get 1 as our remainder. So 5 and 1/3 equals n. And in 3, p is being multiplied and added. So I'm going to subtract a half to both sides to get that variable term by itself. Now I have negative 2/3 p equals 5/6 minus 1/2. I need a common denominator, which between 2 and 6 is 6. I don't have to change my 5 because my 6 already was a 6, but to go from 2 to 6 I have to multiply by 3. If I change my denominator, I have to change my numerator. Here, now that we have a common denominator, I can keep that denominator, perform the operations on my numerator. This is going to give me 2 over 6. Which if we want to, we can reduce here. I can take a 2 out of 2 and a 2 out of 3. Sorry, a 2 out of 6 and get 3. And I have 1/3. So negative 2/3 p equals 1/3. Now, p is being multiplied by negative 2/3. We get rid of multiplication by a fraction by multiplying by the reciprocal, which is the same as if we divide by a fraction, we end up multiplying by the reciprocal anyway. So here I multiply, since I changed my left side, I have to change my right side the same way. Negative 3/2 times negative 2/3 gives me 6 over 6, which is just 1p. Here, I simplify if I can. 3 divided by 3 is 1. 3 divided by 3 is 1. So I get 1 times negative 1 over 1 times 2. And when I simplify here, I get negative 1 over 2. So p is negative 1/2. And that's all I have for section 5.6.